Evaluate double sigma j into NCI, where I and j lie between 0 and n, I being less than j. The terms represented by this double sigma are 1 into NC0 plus, 2 into NC0 plus NC1 plus, 3 into NC0 plus NC1 plus NC2 plus, 4 into NC0 plus NC1 plus NC2 plus NC3 plus, etc. n into NC0, NC1, NC2, etc. till NCn minus 1. Let's observe why. Here j is a factor and j can go up to 1, up to n. So if j is 1, 2, 3, 4, etc., keeping the j varying from 1 to n, NCI, observe that I is strictly less than j. So when j is taken 3, I can go only up to 2. When j is 2, I will go up to 1 only. When j is 4, I is going up to 3, etc. When j is taking n, I will go only up to n minus 1, NCI. Also, why the j is starting with 1? Because no choice of having j equal to 0, because then I doesn't have any option to take. So this is the sum we need to find. Let's find. Here I am adding these vertically. NC0 into 1 plus NC0 into 2 plus NC0 into 3 plus etc. Taking NC0 common, we have 1 plus 2 plus 3 plus etc. till n. Now, next is NC1 twice, NC1 3 times, NC1 4 times etc. we are adding up. Notice that NC1 is starting only from 2. 1 is missing. So NC1 into 2 plus 3 plus etc. till n. Then next is NC2. NC2 will begin from 3 and the summation will go up to n. So NC3 into this, etc. Going up to last one. NCn minus 1 is only n times. It's here. Now we observe the first term. First term bracket is 1 plus 2 plus 3 plus etc. till n, which is sum of first n natural numbers, which is n into n plus 1 by 2. And in the next one, the summation is starting from only 2. So we can say this is summation of first n natural numbers, but 1 is missing. So we write it as n into n plus 1 by 2 itself, but minus 1. 1 is missing with NC1 coefficient. Next is 1 plus 2 is missing. So n into n plus 1 by 2 minus 1 plus 2 subtract for this one, etc. 1 plus 2 plus 3 is subtracted from this one because it's starting only from 4. 1 plus 2 plus 3 subtract. Last term also is going to be written in this pattern. We are going by a pattern. So this I am going to rewrite as NCn minus 1 into n into n plus 1 by 2 subtract summation up to n minus 1. Because what you need is just an n. Now, coming back to this. Here in these brackets we observe many terms like terms. NC0 these many times, NC1 these many times, NC2 these many times, NC3 this blue bracket is common. Hence, I'm going to take them common and write it like this. n into n plus 1 by 2 is common. NC0 plus NC1 plus NC2 plus etc. till NCn minus 1. Now, remaining terms also come up. From there, I collect another group of terms. Here it is 1 into NC1, 2 into NC2, 3 into NC3, etc. in minus 1 times NCn minus 1. That's collected out here. Here. Still we are left with few more. That is 1 into NC2, 1 plus 2 into NC3. Then next will be 1 plus 2 plus 3 into NC4, etc. 1 plus 2 plus 3, etc. till n minus 2 into n minus 1. NCn minus 1. These are the terms. Going further, coming to the first term, this bracket. We have a formula. NC0 plus NC1 plus NC2 plus etc. till NCn, that is equal to 2 raised to the power n. But here in this bracket we notice last term NCn is missing. NCn value is 1, so you subtract 2 raised to n minus 1. Here it is. Then going ahead, simplifying the middle term, this one. NC2 into 1. This one I am writing as 1 into 2 by 2. Again we are forming a pattern. Here 1 plus 2 is added as an AP, two terms having common difference 1. So then we have 2 by 2 into 2 plus 1, that is here. Next would be 1 plus 2 plus 3 would have been there. 1 plus 2 plus 3 is 3 by 2 into 3 plus 1 by 2. Here it is. Similarly, the last one will be NCn minus 1 into the summation is of n minus 2 terms. So n minus 2 by 2 into n minus 2 plus 1 using the formula first term plus last term in the SN formula. Going further, simplifying what is NC2. Let's complete this set first, this group first. That is, NC2 is n into n minus 1 by 1 into 2 into 1 into 2 by 2 copied. As you can see, this 1 into 2 will get cancelled. Next one will give NC3 is n minus 1 n minus 2 by 1, 2, 3. Observe again, and 2 into 3 will go, cancel, etc. The last one, NCn minus n1 is n. N into this one copied as it is. Simplifying further, cancelling this 1 into 2, what we are left with is n into n minus 1 by 2. Here you are left with n into n minus 1 into n minus 2 by 3 into this 2, etc. So we can take n into n minus 1 by 2 common. You are left with 1 here. 2 and 3 getting cancelled. The remaining is n minus 2 by 1 only, etc. Here, this bracket once more we are going to write in terms of the combinatorial coefficients. N minus 2 by 1 is n minus 2c1. This is n minus 2c2. This will be n minus 2c n minus 3. This is n minus 2c1. So n minus 2c is 0, n minus 2c1, etc. n minus 2c n minus 3. This is starting with n minus 2. So if it goes up to n minus 2c n minus 2 itself, it would have followed that formula once more. 2 raised to n minus 2 it would have been. But again one term is missing. The last term value is 1. So it's again 2 raised to n minus 1, 2 raised to n minus 2 minus 1. Here n minus 2c was 0, n minus 2c1. So 2 raised to n minus 2. Subtract 1. Now we'll go ahead simplifying these terms also. Here NC1 1, NC2 2, etc. Copying them. Now simplify. NC1 is n. NC2 is n into n minus 1 by 1 into 2. Into 2. NC3 into 3 is coming. This 3 and 3 will get cancelled, etc. In this bracket, we have a factor n common. Take it out. We are left with 1 plus, etc. etc. I'm going to rewrite these terms as n minus 1 c1, n minus 1 c2, etc. The first term 1 being n minus 1 c0. Once more the same formula pattern. Again notice one term is missing. Its value is 1. So this bracket will give us 2 raised to n minus 1 subtract 1. Already we have the first term ready. Bring it down. So the 3 terms are calculated. 3 series are calculated. Here again we observe some like terms are there. 2 raised to n, 2 raised to n minus 2, 2 raised to n minus 1. Multiplying them. Collect these 3 terms first together. That is n into n plus 1 by 2 into 2 raised to n minus n into n minus 1 by 2 into 2 raised to n minus 2 minus n into 2 raised to n minus 1. Collected these many terms. Then we have minus n into n plus 1 by 2 minus 1, n into n minus 1 by 2 minus 1, subtract n into minus 1. So we have these many. The second terms collected out here. If you simplify this, we will notice this whole bracket is simply 0. And here, 2 raised to n upon 2 is 2 raised to n minus 1. 2 raised to n minus 2 upon 2 is 2 raised to n minus 3. Here it is 2 raised to n minus 1 itself. Simplifying each power of 2. And this term already I discussed, it's 0. Now from these three terms, I'm taking 2 raised to n minus 3 common. If I take 2 raised to n minus 3 and 1 n also common, I'm left with 2 square into n plus 1, which is 4 into n plus 1, minus n minus 1 minus 4, taking common. Simplifying this bracket, I'm getting 3n plus 1. So the summation is 2 raised to n minus 3 into n into 3n plus 1.